Okay, so we have just only finished two parts of many parts. Okay, so let's just try to settle this video using settle these two parts using this video. Okay, so therefore let's just start. So I'll just do up the multiplications and the division first. Alright, so if you, I'll just start with an example also. So eventually you have maybe 55 times 10. Alright, you actually shift your 55 with a 0. If I have 55 times 100, I actually shift it to 5500. Right? So as you can see, your 55, you switch it, you have two more zeros behind. Over here you have one more zeros behind. Alright, you see the difference? So if it's 55 times 1000, you'll have 55, 3 zeros. Alright, the trend that is coming up. Alright, so I'm gonna use this thing to actually share with you something. The multiplications and the divisions are only multiplication and division by 2, by a factor of 2. Okay, so if I have like 0, 1, 1, 0, if I were to multiply by 2, for example, times, how should I rewrite this? Okay, I think this is a better example. If I have 3 times 10, I can actually rewrite as 3 times 2 plus 3 times 2 square. I think, is it 2 times square? Wait, 3 times 2 cube. Alright, so this is 3 times 2 plus 3 times 8. So 3 times 2 is what? 3 times 2 is 6. 3 times 8 is 24. So 24 plus 3 is actually equals to 30. Alright, so you can actually write your, when you do multiplications in Arduino, this is how they actually dissect the things. So I don't know whether is it true but this is how we do multiplication and divisions for binaries. Okay, so therefore your 3 over here can be re-represented as 0, 0, 1, 1, right? Because this is 2 to the power of 1, 2 to the power of 0. So 2 to the power of 1 plus 2 to the power of 0, this is 2 plus 1 is equals to 3, right? So I can rewrite my this thing over here as 1, 1 times 2, okay, plus 0, 0, 1, 1 times 2. Okay, so if I have a multiple of 2, normally I will want to write in terms of a factor of 2, right? Because our binary is in terms of 2, right? 2 to the power of cube, 2 to the power of square, 2 to the power of 1, 2 to the power of 0, 2 to the power of 4, right? So everything is in terms of 2. Okay, so therefore if that's the case that happens, if 0, 0, 1, 1 times 2, I'll have 0, 1, 1, 1, 0. Okay, actually this is 2 to the power of 3. Sorry, I didn't actually write it properly. Okay, so over here as you can see 0, 1, 1, 0. Okay, I actually shift it. I actually shift this up over here. Okay, you see? Same thing like just now the 55. If I want to multiply by 100, alright, this 55 I actually shift it forward and then behind I put it as 0. 2 zeros over here. So this thing over here is somewhat like this is base 10. If you still remember, all your numbers are base 10. Over here are all base 2. Alright, so it acts at the same purpose. Okay, so if you want to try that again, I can actually try with this one. So 0, 0, 1, 1, I actually have 2 cube. Alright, so I'm gonna shift by 3 times. So I'm gonna shift this thing 1 time, shift 2 times, shift 3 times. So end up I will have 1, 1, 0, 0. Okay, so at first I have 0, 0, 1, 1, right? Then after I shift it 1 time, 2 times, 3 times, I have this one. Hope you kind of get what I mean, right? So this thing over here, 2 to the power of cube, is much like 10 to the power of 3 if you talk about the 55 times 10 to the power of 3 example. Alright, so this 10 to the power of 3 will give you 3 zeros at the back. Alright, so same thing over here. Now you have 3 zeros at the back also. Okay, so I actually shift this 1 time, 2nd time, 3rd time. Okay, but I just want to convey that this works. So later on I'll do some examples again also. So over here this is 2 to the power of square, right? So this is 2 to the power of 1. So 4 plus 1 is actually 5 plus, alright, this thing over here is 2 to the power of 4, which is 8. So this is 2 to the power of 5, which is 16. Alright. Let me see. This is 2 to the power of 2, 2 to the power of 1. This is equals to 4. 2 to the power of 1 is actually 2. So it's 6. Alright, I actually calculate wrongly. I'm a bit tired already. Alright, but anyway, this is 6 plus, this is 2 to the power of 4 plus 2 to the power of 5. So it's 16 plus 8. So this is total 24. So 24 plus 6 is equals to 30. You see, it's the same as this one. Alright, so the key concept that I want you to know is what? For example, if I have a 1 byte system, I have 8-bit over here. Okay, if I say that I take this value, alright, this is what? This is 2 to the power 4 and 2 to the power 3. So in total this is 8 plus, is it 8? Actually this is 2 to the power 3, sorry. This is 2 to the power 3, 2 to the power 2, 2 to the power 1, 2 to the power, yeah, correct. So this is 8 plus 4, 12. Okay, so I have 12 over here. We can just write as equals to 12. Alright, so if I were to take 12 times 2, I'll have 24. Alright, where this binary number is 24. Okay, which this is 2 to the power 4, this is 2 to the power 3. So 16 plus 8 is equals to 24. Okay, so as you can see, I multiply by times 2. When I multiply by times 2, this 1 actually shift it up one step. You see, actually transcend to another step. Okay, where I actually shift this over here. Okay, you see? So if you don't believe me, I can actually go on. I can actually multiply by another times 2. So in other words, if I were to take this off, alright, I actually multiply by times 2 to the power of 4. Alright, so I'm gonna jump 4 times. Alright, so I'm gonna copy this thing and I'm gonna jump 4 times. Okay, so I'll just bring this down first. Alright, I'll just write as 0 over here first. Okay, later you know what I mean already. So over here, I'll jump 1 time. Yeah, wait. Okay, this is better. Alright, so I have this one over here. Alright, the same thing as the system. Okay, so I jump 1 time, bram, 2 time, bram, 3 time, bram, 4 time, bram. Okay, so because it's 2 to the power of 4, so I jump 4 times. Okay, so I have this value. Okay, if I were to evaluate this value, what I will have is, this is actually 2 to the power of 7, this is actually 2 to the power of 6. If you add 2 to the power of 7 and 2 to the power of 6, you will get 192. Alright, let's evaluate 12 times 2 to the power of 4. Eventually you get also 192. You see? So you see the multiplication come in already, the trend. Alright, so normally you, when you do multiplications, you do in terms of this method. Alright, if you were to ask, use binary to solve for this multiplication, 7 times 3. Wow, siao, these are all odd numbers, right? So how can you do? Just now what I do is all even numbers. 3 times 10, wow, sweet, we got a to the power of, you know, we got 2, we got even numbers. Over here, siao, right? Cannot do anything. What can I do about this? Alright, then you're a bit stunned already. Alright, so what you can do is, therefore I can write in this form. 3 times 2 to the power of 0 plus 3 times 2 to the power of 1 plus 3 times 2 to the power of 2. Okay, so I can actually break 2 to the power of 0 plus 2 to the power of 1 plus 2 to the power of 2. You see, so 2 to the power of 0 is actually 1, 2 to the power of 1 is actually 2, 2 to the power of 2 is actually 4. 4 plus 2 plus 1, 7. So I can first break them down into this form first. Alright, it's very subtle, but you can just try it out. Alright, so normally you can try 3 to the power 3 times 2 to the power of 0 first, because 2 to the power of 0 actually is an odd number, 1. Alright, so you can straight model the 3 quite well already. Alright, and the rest goes on. Nonetheless, you can also do in another way of solving things, you can write as 7 times 2 to the power of 0 plus 7 times 2 to the power of 1. 2 power of 0 is what? Is 1. 2 power of 1 is 2. So 2 plus 1 is 3. Alright, so you have two methods to actually solve for your this type of question. Alright, you just need to know how to rearrange. Alright, so as you can see, if you want your 3 to be the subject, so this 3 is all placed over here. Then the 7 you dissect into the terms of a binary, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. Alright, so you need to know how this thing, I can't help you much because I can only show you the examples to do. Alright, so never mind. So in this case, I see that this is actually a smaller step for me. I'll just rewrite over here. Okay, so I'll just briefly go through review this thing, and then the rest you own self go and take a paper and write yourself. Alright, so at least you get a feel of things lah. So I can rewrite the 7 as 0, 1, 1. Alright, this is 2 to the power of 2, 2 to the power of 1, 2 to the power of 0. So it's 4 plus 2 plus 1, which is 7. So I can write in terms of the binary, multiply by 2 to the power of 0. Alright, so in this case, I didn't jump anything. 0, 1, 1, 1, that's all. Okay, so I leave it here. Plus 7 times 2 to the power of 1. So 7 is 0, 1, 1, 1. Alright, so 2 to the power of 1 is actually times 2 to the power of 1. So I'll shift the whole thing, alright, by a step forward. Okay, so I have 1, 1, 1, 0. Previously was 0, 1, 1, 1, right? I bring all this 1, I shift it to a next step. So I have 1, 1, 1, 0. Okay, so if I have 0, 1, 1, 1, and if I were to have 2 to the power of 3, then you're going to shift 3 steps. Alright, so I'm going to talk about taking in another 4 bits. Alright, so I have 1, 1, 1, I'm going to shift 1 time, 2 times, 3 times. Alright, so at the end of the day, I will have this thing. You see? So I actually shifted quite, maybe I should write it down again. So for example, I have 1, 1, 1, 0. Alright, if I shift to the power of 3, okay, for example, alright, I shift 1, 2, 3. Okay, so I have this thing. But in this case, we are only talking about 2 to the power of 1. So I'm actually shifting only to the power of 1. I only shift 1 time. Okay, and therefore I no need. So therefore this 1, 1, 1, 0, I shift only 1 time. Wait, where am I over here? Alright, I'm gonna take this. Alright, I'm gonna shift 1 time. See? Where am I? Wait, I'm gonna shift 1 time all over here. Okay, wait, oh, my 0, 1, 1, okay, sorry. My 7 is actually here, damn it. At least you get what I mean now, okay? This 0, 1, 1, 1 over here, so if you shift 3 times is 1, 2, 3. Alright, so in this case we are shifting only 1 time, so I shift 1 time, I have 1, 1, 1, 0, which is this value over here. Sorry, I suck. I actually a bit tired already. But anyway, you get the meaning of that already. I hopefully you get the meaning. Yeah, otherwise then I'm very sorry. So nonetheless, if you add it up, you should get, so 0, 1, 1, 1, if I add it up, is 1, 1, 1, 0. So 1 plus 0 is 1, 1 plus 1 is 1, bring forward 1, so 1 plus 1 is 1 plus 1, which is 1, I bring forward another 1, so 0, so 1 plus 1 is 1, so I have 0, 1. Okay, so these are the things. If you don't understand what I'm doing right now, this is because you haven't go through these videos. Alright, so I'll just suggest you watch these videos, the summing one first. Alright, so over here, if you were to evaluate this thing, you should get 21. So this is 2 to the power of 5, 4, 3, sorry, this is 2 to the power of 4. 2 to the power of 3, 2 to the power of 2, 2 to the power of 1, 2 to the power of 0. So 2 to the power of 16 plus 8 plus 4 plus 2 plus 1. So over, wait, what am I doing? 2 to the power of 3 is actually 0. I mean, for this case this is 0, so this is 0 plus 2 to the power of 2 is actually 4 plus 2 to the power of Wow, damn it, I'm really tired. 1 plus 0 is actually 1. 1 plus 1 is actually 0. Bring forward 1. 1 plus 1 is actually 0. But with this 1 over here, I have 1. I bring forward 1. So 1 plus 1 is 0. I bring forward 1. Okay, so this is 16 plus 0 plus 4 plus 0 plus 1. Alright, so 16 plus 4 is 20, 20 plus 1 is 21. Okay, so yeah, these are all class mistakes. So be very careful when you do this lah. Okay, and I think later on we'll do an example, but at least we somewhat clear away the multiplication. The division is simply the same method, but you are moving in the opposite direction. Previously, multiplications will actually shift forward. Alright, we shift forward to based on the power of the 2, right? So in the division, you actually shift backwards. So you shift backwards. Okay, so these are the meaning to the division. Okay, we wonder if I have shifting, if I divide, then am I shifting back? So if I shift back, do I need to add in other values? Alright, do I need to add in zeros at the back? Because I'm shifting backwards already, you see? So I'm actually shifting backwards. Because this is the last part of the binary, if I were to divide by 2, am I shifting backwards? If I were to shift backwards, then am I talking about other stuff? And indeed, we are talking about other stuff because we are going to introduce you with decimals. Alright, because if you're talking about, because 7 divided by 2, for example, 7 divided by 2 is equals to 3.5. Alright, it's talking about decimals. And in this case, we can't represent decimals over here. So therefore, this is a constraint. Alright, therefore, in the next video, we'll talk about it. Alright, but I hope that this briefly gives you the understanding of the multiplication and the divisions a little bit clearer. Alright, next video I'll do a few exercises. I'll do a few random exercises so that you can fully understand what I mean. Alright, but meanwhile, I'll talk about the overflow and carry. Alright, overflow and carry, if you remember, is simply what we have done just now. Alright, is for example, I have 1 1 1 1. Alright, 1 0 0 0. So over here, 1 plus 1 is 1, 1 plus 0 is 1, 1 plus 0 is 1, 1 plus 1, alright, is actually 0, and I bring forward 1 to another 4-bit system. Alright, so it's 0 0 0 1 over here. Alright, so you can actually bring forward, and this is called overflow. Alright, so what I've been doing just now all along is called overflow. Alright, or we can call it the carry. Alright, so if you were to extend to these definitions, you may not understand a bit. Alright, so I'll just somewhat crop it out. Therefore, if I were to put this, alright, if I were to put this in this portion over here, I think this will be more clearer to you. Okay, I'll name this a lower byte and I'll name this the higher byte. Alright, because 1 byte is 8 bits, right? So I have 8 bits all over here right now. Okay, yeah. So this is my my system over here. So if I were to multiply by times 2, you know that we're gonna shift by one step. We're gonna shift over to the, or in other words, we're gonna shift this particular one to the side. Alright, and then at the behind we'll add a 0, right? Because we actually shift this whole chunk by 1 time. Alright, because we times 2 to the power of 1. Right, so therefore 2 to the power 1 is just shift. It's the same thing lah, like it's times 2 to the power of 1. Okay, I'm actually shifting. For example, if I'm here at first, if I times 2 to the power 1, I shift over here. Okay, so if it's times 2 to the power of 2, I actually shift it 2 times. Alright, I'm repeating myself because I feel I'm inadequate enough. So I shift 2 times. So this is my answer. Okay, so if I am shifting maybe 5 times, alright, times 2 to the power of 5. So therefore I'm gonna shift 5 times. Alright, so I'm gonna shift 1 time, 2 times, 3 times, 4 times, 5 times. Okay, so this is my answer if I am 2 to the power of 5. If I when multiplying with 2 times 8, if I am multiplying with 2 to the power of 5, then I'm simply shifting by 5. Okay, so therefore this is the same thing over here for the high byte and the low byte. So at first it was this thing over here, and then because of the multiplication, if you still remember just now what I did earlier, at first it was like this, right? If I were to take this thing, I multiply by times 2 to the power of 1. Same thing, I'm gonna bring this whole thing forward by one step. Alright, this one will actually overflow to this side. Alright, while the behind will actually end at 0 over here. Okay, so this is the thing that this page is trying to tell you. Alright, and this method is just simply the overflow and carry lah. Alright, but in a way that is, yeah, it's not very, yeah. Anyway, at least you get a feel of these things. So in the next video, I'll strengthen your understanding by putting up a few examples so that you can fully understand the things. So see you there.